Okay, we're going to look at lesson 1.9 notes on solving our linear equations. So this is the second part. Again, a lot of review. Notice our first review here is on writing that story, which you're getting a little bit better on, but making sure that you're really still working on the fact that, yes, you absolutely must have an intro. You definitely must have that question down there. Have to have a question mark and know what you're actually asking. And then that body has to have that wonderful information about everything else that's in this problem. So it's about that number trick, Lily's number she guessed, Callie's number she guessed. But the big thing that's a little bit different here is that equal sign between these two, between Lily and Callie, which means they are equal. So that's when you're seeing this part right here about realizing their results were the same. And then trying to figure out that answer. Interpreting your answer, that's also a little different with this lesson. That means you're going to go ahead and give your answer to the question in that sentence form using that complete sentences. So once you go ahead and solve the equation, which you can see I did right here, solved it all right here, then I got my answer of -10, but what they're asking for is they want you to then go ahead and give me the answer with a sentence. So they both started with -10. Again, it's a story problem, so we're going to answer it with that English sentence. Looking down at number 2, again, look what it's asking. You have to write an expression for each unknown quantity, write the equation, solve the equation, and interpret the answer. So the very first thing that they're asking is they're asking for you to give me what does each part of the story mean? How are you breaking it down to change it from words into variables and expressions? So you've got the Horizon Phone Company and you've got G-Mobile and you're looking at their rates. So this is what they want you to give. I want to know, what does each part represent? What is the variable you're going to be using? How is it relating to Horizon Phone? How's it relating to G-Mobile? And then writing the equation. So it's asking, notice in that purple line right here, it's actually asking for you to see how many texts would the two plans cost if they were the same. So again, that's where that equal sign is coming into play. And then I'm giving my Horizon Phone and making sure it was the same as G-Mobile. And there's my equation that I'm going to solve. So now you can see over here, we've got all of the solutions showing all the solving actions in my work. But then I've got to be very careful to read the next part of the question. It's not asking me how many text messages will there be, so it's the same. It's also asking which plan would be the better deal if I send 200 texts per month, which means I need to then take what's my Horizon Phone expression and plug in that 200. If G-Mobile, what is the price of G-Mobile going to be? And from there, I can definitely see Horizon is definitely going to be less than G-Mobile. And that's going to give my interpretation that at that rate, definitely Horizon would be the best deal for that phone company. Here in B, same thing. Make sure you tell me what each part is actually representing. So I'm using the T for terms. If you want to use a different variable, you're more than welcome to. And then my expression for the dance class and the choir. And then notice in that purple right there, it is saying what or how many terms would actually be, so the number of students in the class and or both the dance and choir would be equal. So that's where I'm getting my expression. taking that and solving it, showing all of my solving actions right here. And then being careful to notice that last question, how many students will be in each class. It doesn't just mean how many terms where they're going to be. I'm then going to go ahead and take, I don't care which expression, I chose the dance expression, and I'm going to write it in and then substitute in the value I got when I solved it to find out the number of students in both those classes would be 96. And again, writing it in a complete sentence for my interpretation. So now on that last one, we're going to do this one together. If I burn approximately 230 calories less per hour if I ride a bike versus if I go on a run, and Leon went on a 2-hour run plus burned an additional 150 calories in his warm-up and cool down, Theo went on an hour bike ride. If Leon and Theo burn the same amount of calories on their workout, approximately how many calories do they burn an hour for each type of exercise? Well, let's break down where I'm going to make my variable. And I know the number of calories is going to be one of those parts. And I'm going to just go ahead and use the variable C for calories. Now, some of those exercises, calories for biking. Well, it's calories 230 less than riding the bike. So biking would be C minus 230. Calories for running. That's the other exercise. Well, that's just the basic. That is the number of calories. So again, I can just write C, or I don't even have to put it. I can just write calories for running. And now let's look at who we're talking about. Leon. What did he do? Well, it says that Leon right there went on a 2-hour run. So 2 hours times the number of calories per hour. And then it says plus the 150 in his warm-up and cool-down. Theo, on the other hand, it says right there that Theo went on a 4-hour bike ride. So 4 hours, and the bike is C minus 230. And now I know that they actually did it, so they burned that same amount of calories. That's where I'm going to come up with my equation. So it's going to be Leon has to be equal to Theo. And we came up that Leon was 2C plus 150. Theo was 4 times 230 because it was 4 hours of that biking. And now we're going to go ahead and solve it here by using our distributive property on the right for that 4C minus 920. And then, of course, we're going to go ahead and I'm going to subtract 2C to get all my variables on one side. So 150 is 2C minus 920. And now, of course, isolating my variable by doing the inverse operation of the constant. And then inverse operation of my coefficient to find out that C is equal to 535. Now, again, it says approximately how many calories do you burn an hour for each type of exercise? That means I need to know about running and biking. Well, running is easy. That is the calories for running. So let's go ahead and write that out. Again, interpret with words. You burn 535 calories running, and taking your biking, that would be my 535 minus my 230 gives me 305. So there's my other part of the answer, 305 calories biking. So we're just going ahead and working on giving us the breakdown of each part of the story problem, solving it, and then interpreting with a word problem using our words. Again, if you have any questions, go ahead and email me. I'd be more than happy to answer them. And then we will work on some of this again when we meet. Have a great day.